Okay, so today we will discuss about digital voltage measurement techniques. What are the techniques which are used to measure the digital voltage? The basic objective is to measure digital voltage. So this digital voltage measurement is basically done using DVM, which is known as digital voltmeter. So digital voltmeter is an instrument which is used to measure this digital voltage. Now the question arises how this measurement takes place, how we are going to measure the digital voltage using this digital voltmeter DVM. In a short, we call it as a DVM. So what is DVM? Let us first know what is DVM. So DVM is basically an instrument that measure an analog voltage. It will measure an analog voltage which is given as an input to this and displays the reading, whatever reading it will measure of analog voltage. It will display the reading in the form of illuminated decimal numerals. Okay, like we all might have seen the digital display. If we recall the normal DVM, digital voltmeter, suppose we are measuring a value of a voltage of 10 volts, then it will give you 10.00. Here is the panel, here is the switch that we normally select as a voltmeter for ohm, for current. So there are different panels assigned on this board, and using that panel we can measure different voltage. So they are two probes which are coming out of this DVM, which are connected to the input. So once they are connected to the input, the display is the measurement is basically done in the form of illuminated decimal numerals. So this is called DVM. Okay, so normally it is available in the market in white color or yellow color, and the price may be as ranging from 800 to 1000 rupees. So it is available depending on the range that we are having. Okay, so this we can achieve, this we can have from the market itself. Now let us consider that what are the sub part of this DVM, digital voltmeter. So if we broadly categorize, there will be few parts that I will discuss one to one. I will also discuss what are the advantages of using digital voltmeter over the analog voltage measurement, analog voltage, then how they are different. Obviously the accuracy will be the essential part while measuring with a digital voltmeter. So let us come first to the parts, the various parts using in DVM. So DVM basically consists of ADC. ADC we have studied in detail, that is analog to digital converter. So this analog to digital converter we have already studied in the previous classes. We are very well familiar the functioning of ADCs. Then we need to have a decoder that will decode that analog information into the binary coded decimals. So that binary coded decimal is displayed onto the front panel of the DVM, and we require a display units. Various types of display units are available, and they may be some pen and pencil based, they may be illuminated number type, they may be some alphanumeric. So like this is one type of display that we have using in this type of category. Okay, this is one type of display that we have. So this is called the digital display. This is called the digital display. So this display is illuminated over the front panel of the DVM. So this is some brief introduction about the digital voltmeter. Basically DVMs are identified by the type of ADC used. I mean, if we are going to the market, if we are asking for any of the DVM, then we must be specific while measuring the ADC, which type of ADC we are using. So the type of ADC we are using, the same is the type of DVM. Okay, so basically we can say that different DVMs are identified by the type of ADC used. So there are many variety of DVMs as the number of ADCs are available. Number of ADC are available in the market. So number of DVM can also be manufactured with the help of ADCs available in the market. Okay, now let us see the next part of it. Basically let us discuss something about what is digital signal, what is analog signal, because these are the two signal which are employed, which are given to the digital voltmeter for their proper function. So let us recall what is a digital signal. Normally the signal which makes abrupt transition between two well-defined level is called a digital signal. So what is the digital signal? Basically the digital signal is which makes abrupt transitions between two well-defined level or called the digital signals. Similarly, the signals which may assume any value in a continuous range is called the analog signal. What is analog signal? The analog signal which may assume any value in a continuous range is called analog signals. Okay. So once we process analog signals, these are often a great advantage in converting the signal to digital form so that processing can be done digitally. Okay. So based on the above discussion, let us summarize the advantages of using DVMs. What are the several advantages? So one advantage of having DVM is that it is basically gives an unambiguous, easy to read numeral indication on a display panel. Okay, there is no ambiguity once we read the digital display is the crystal clear display, while as the analog there is a misconception, there is a error in while reading the input which we have measured. Suppose we are measuring 10 volts, so in case of analog voltage we may measure 9.8 volts, 9.5 volts due to the parallax error, which is called parallax. We are all, I'll write it here, the error called by parallax. So this error is very well aware. So analog instruments, mostly all of the analog instruments suffer with this type of error. This is known as parallax error. Okay. The second advantage we can have using this digital DVM is when a time varying signal is transmitted, as it is over long distances, noise is superimposed on the signal. Noise is the root cause. So when it is transmitted over the long distance, the noise is superimposed. So most effective way of suppressing noise is to transmit the signal digitally. So once we transmit any signal in the digital form, the noise is suppressed. So this is the another advantage of using the DVMs. Suppose we are transferring analog data, analog form, so there may be noise which may hamper the original signal, and the receiver signal will be the distorted version. So to avoid this, what we need to do is we need to transfer the signal into the digital form. Okay. The next point we can as an advantage of this DVM is digital filters, microprocessor computers may be used for processing. That means if we are transferring the data in the digital form, there are some mode of communication. What are the mode of communication? The mode of communication are digital filters, microprocessor computers may be used for processing. Okay, so these are the way through which we can measure. One more additive advantage of using DVM is that a number of signals can be processed simultaneously. A number of signals can be processed simultaneously. Suppose we have 2 or 3 signals, all these numbers can be processed and can be displayed based on the priority level set by the instrument. So these are the advantages. If we recall the advantages, there may be 3 to 4 advantages while using the DVMs in the digital voltage measurement techniques over the analog voltage. So in the next part we will see that what are the types of ADC, because ADC is the main part of this DVM. So we will see the type of ADC which are used to manufacture the DVMs. So we will see the indirect type analog to digital converter in the next class. Thank you.